So this will be a simple problem related to divergence, curl, and gradient of a given function. In the first question, I have here a function depending on x, y, and z, and then I have to find the gradient of this one. Whereas in the second question, I have another function, vector function, x, y, I hat plus y, z, z hat plus z, x, k hat, and then I'm told to find the divergence and the curl of this one. Alright, let's start with the first problem. So it wants us to calculate the gradient of given function. That is, it wants us to calculate the delta f, which is actually I df by dx plus z df by dx plus k df by dz. So this is because we have delta is equal to I d by dx plus z d by dy plus k d by dz. And then we also have f x y z is equal to x squared plus y squared plus z squared. Now, when I'm taking the partial derivative of f with respect to x, y and z will be considered constant. So the first term over here will give me twice x, because the derivative of x squared with respect to x is twice x. Whereas this two quantity won't be giving me anything. Similarly over here I'll be getting, and then finally over here I'll be getting twice z. So this will be finally twice x I hat plus twice y z hat plus twice z k hat. And all of you can see the gradient of any scalar function will give me a vector quantity. Alright guys, let's now go to second problem. So in second problem I have a vector function f. Actually it's denoted by v over here, but it's a typo, so this is f. So f is actually equal to xyi plus yz z plus zxk. Now I'm told to calculate the divergence of this function in first question. So if I calculate its divergence, this will give me I d by dx plus z d by dy plus k d by dz dotted with I fx plus z fy plus k fz. So over here, whatever this is fx, this is fy, this is fz. Right? So if I proceed further, when I'm taking dot product, I have already mentioned in my previous video, so this will be like partial of fx with respect to x plus partial of fy with respect to y plus partial of fz with respect to z. So partial of xy with respect to x plus partial of yz with respect to y plus partial of zx with respect to z. As I've already mentioned over here, so this particular quantity y is now considered constant, so it will come out. So it will give me y. Over here the quantity z will come out, so dy by dy will be again 1, that will give me z, and then over here I'll get x. So my final divergence will be x plus y plus z. You can clearly see over here this is a scalar quantity, so that is perfectly in agreement with our previous question in previous video. So if you do a dot product between any two quantities, you should be getting a scalar quantity. That's why we call it scalar product. Nice. So we are finally back to our third problem. So over here in third problem, we are supposed to calculate the curl of given vector f. So if you actually review the definition of curl, it can be actually written in determinant form. So it can be written like I say k and then dy dx, dy dy, dy dz, and then finally if the vector is f, x component of vector, y component of vector, and then z component of vector. So if I expand this, I can actually expand this in such a way that the I component will be actually dfz over dy minus dfy over dz, plus z component will be so dfx over dz minus dy dx of fz, and then finally the k component will be dy dx of fy minus dy dy of fx. Alright, so now the partial of fz with respect to dy. So we have this vector function fxyi plus yz z plus zxk. So this is my fx, this is my fy, and then this is my fz. So if I go here over here, dy dy of fz, where is our fz? It's over here. So fz, this quantity is actually 0, minus dfy over dz. So this quantity will actually give me dfy over dz. It will give me y, right? Similarly over here, if I go ahead and calculate this quantity, so with respect to z, it's again 0 because I don't have z over there. And then over here, if I actually take the partial derivative of partial derivative of fz with respect to x, it will give me z. Finally, the third term over here, if I take partial derivative of fy with respect to x, I don't have any x sitting in fy, so that will give me 0. And partial derivative of fx with respect to y will give me x. So finally, I'll be getting minus y I hat minus z hat minus x k hat. Okay guys, so finally we got the curl of given vector f to be this much. So from here you can clearly see that this particular quantity is a vector quantity. So that's it for today. I hope you have learned something about the divergence and the curl and the gradient of given functions. So I'll be posting different conceptual problems regarding vectors or other some physics topics in my later videos. Till now, thank you so much for paying attention, and I hope you will like my video. If you really like it and if you really feel that it's helpful for you, please don't forget to subscribe it. Thank you.